Hello, everybody. Welcome to AP Stats Reading Computer Output. All right, well, here we go. So the computer outputs on the AP exam, they'll look like this. There's a whole bunch of information that we don't really ever use, and some we need to like translate from that, okay? So here it tells you, and there'll usually be like a paragraph above, this model predicts mile time in minutes. Okay, that's your response variable that would be on your y-axis right there, whatever it's predicting. Okay, from cardio hours per week, that would be my explanatory. Okay, so somewhere in the paragraph, you need to find the response or the y-axis part of the problem. Okay, it's in the text usually up there. All right. Okay, if you notice all these things here, okay, the thing I'm looking for right now is constant. Okay, that is your constant value or non-changing value, which is your y-intercept. Okay, that is your intercept right there. Okay, also directly below that is where you'll find the slope of the equation. Okay. You'll also notice that in our equation of our line, it's y equals a plus bx. B is the slope, it goes with the x. Okay, so the x is attached to the b like that, to the slope. And this is your x value right there. Okay, so constant will tell your y-intercept. And then directly below that, you'll find something else. And that's your slope right there. And then this word here is what gets plugged into your x variable, excuse me, okay? The other value we're going to want, we want r and r squared, okay? We're interested in this one, okay? We do not use r squared adjusted. All right, there's a problem with this a little bit because r squared is 0.74. And if you'll notice, if I had r could be negative or positive. But once you square it, it's always going to be positive. So by looking at this, you cannot determine if r is negative or positive. Remember that a negative correlation just means going downhill. So what can we do? We can look at the slope to determine that. In this case, my slope is negative, so my line would be going downhill. So my r value is going to be a negative. Again, it won't show up here, okay? All right, let's go ahead and write our equation of our line. Okay, and then we're going to give the value of the coefficient r, excuse me. Okay, our equation of our line. Let me get this out of here. Remember, you need the hat on there when you do your equation, and you need to explain it in context, the x and the y. So our equation, okay, my intercept, 17.3. Okay, plus or minus my slope, in this case it's negative. Negative, my slope, 0.21x. Okay, and we saw that x is right here, it's cardio. And there's no units there, which are really important because it could be hours per day, minutes, whatever it is. Okay, but somewhere they have to tell you it's cardio in hours per week, and then we'll have our mile time in minutes. Remember that your y-hat stands for your predicted. It was in minutes there. Okay? All right. Our correlation coefficient, we're looking for r. We know that r squared is 0.74. Okay, so from that, we're going to go ahead and square root that to get r. Okay, plus or minus again, because r squared is always going to be positive, and we have to determine if it's positive or negative, the r value, by whether the slope is negative or positive. In this case, our slope is negative 0.21. Again, that's going downhill. We have negative correlation, our r will be negative. Okay, so all I have to do is square root 0.74. That is 0.8602. once again, it's negative because our slope is negative. That's how I can tell. Okay? And from that, I would be able to answer all of the information. I would be able to explain the correlation, the coefficient of the line of best fit. This would be a y-intercept, meaning whenever your x, which should be your cardio hours, was 0, that'd be the predicted mile time, 17.3 minutes, okay, which is really slow. Even I could do that. All right, and a slope of 0.21, negative 0.21, would indicate that for every one more increase in the x, for every hour per week of cardio increase, there would be an expected 0.21 minute decrease in the mile time. All right, our correlation was 0.86, which is in the strong category. It's negative. A correlation of negative 0.86 would indicate strong negative correlation between cardio and mile time. Last one, coefficient of determination, which is given right here, at 0.74, indicates that approximately 74% of the variation, whatever your y is, mile time, is explained by the least squares regression line. All right? Okay, that's it for the day. Thank you.